All right, in the beginning of chapter 2, 2.1 specifically, the main focus is getting comfortable with domain and range when you have sets of data and understanding what makes a function. What is a relationship, which is any set of data, versus what it takes to actually be a function. So I'm going to take you through just some basic examples, and then I'm also going to show you some delta math examples so you get an idea of what you're going to be asked to do. So when you're talking domain and range with a set of numbers, your domain are going to be your x values, so 1, 3, and 5. And I can just list them, 1, 3, and 5. And then your range are going to be your y values. You should always associate domain with x and range with y. So your range is 2, 6, and 10. And they can be written in numeric order or they don't have to be. We can write it as a list when we have a set of points. So again, domain, you always want to associate domain with x and range with y. I'm going to have you look at some visual ones in another video that will help that process as well. Anything is a relation. So when we talk about sets of data, yes, we have a relationship because we have 1 going with 2, 3 going with 6, 5 going with 10. And I can give you any set of data. They don't even have to be numeric, and it would be a relation. I could give your name and then your height, and that would be a relation because there's a connection between your name and how tall you are. A function, though, is very specific in how it works. In order to have a function, then every x, each of my x values or each of the values in my domain has to map or go with one y value. That's a really simple way to define a function. Everything that's in the input or the x values, your domain values, can only have one partner. So if I have an example would be like your social security number. So your name goes with your social security number. There aren't multiple options. At the same time, though, something that's not a function in real life could be something like if I made a table of the ages of people in the class and how tall they were. Because you could have a whole bunch of people in the class that are 15 or 16 years old, and they would have many different heights because one person could be 16 and 5'3", and one person could be 16 and 6'2". So you have different outputs for the same input. That would be something that's not a function. So there's some different ways to write function, like write different input and output and determine a function. So this first one is called a mapping diagram, and this is what Delta Math uses a lot. In your mapping diagram, your x's, your input, are going to be in the first column. So this is going to be your domain values, and your y's, your output, are going to be your range values. Another way to do it is put it in a table, and that's probably what you're most comfortable with, is put it in an XY table. So same thing here. These are the same numbers, but you can see the domain and you can see the range. This bottom one is another example of a mapping diagram. Again, domain is your input and range is your output. And if I wanted to check to see if it's a function, I am looking to see that everything in the input column has one partner or one data point in the output column. So these examples, these first two, these are a function because every x has one y that it goes with, or every input has one output. I wanted you to see an example of one that wasn't, so you kind of know what you're looking for. If you look at the bottom example, this bottom example is not a function, and the reason is right here. Let me kind of highlight the reason. You look at the input value 0, and if I said, what does 0 go with? Well, some of you could say 2, some of you could say 3, and you're both right. That right there is not a function because we have an input value that is repeated with 2 different output values. So 0 goes with 2, and 0 also goes with 3. So this would be an example that is not a function for that reason, because 0 has 2 different output values. So in Delta Math, let me get there. They're going to give you questions like this where you have to determine if it's a function and fill in some of these data points. So this one, if you look, all your values in your input, so set A is your input, they are all different. And they all have a y value or a output value that they match with. So 9 only goes with -2, 6 only goes with 2, -1 only goes with 2, and 0 only goes with -4. So when I'm doing one like this, I would say that this represents a function since there, for each number in the input, make sure you have the right one here. So set A input. Each number in the input, there is only one mapping in my output, which is b. So that's what they're looking for you to do in delta math, to explain if it is a function, then the reason it's a function is that every number in the input, which is going to be set a, has only one value it maps to in the output. So let me show you, I want to show you one that has an issue so you know how to deal with it. So here's a great example of one that's not a function. So this particular one is not a function because, and the key here again is this value right there, that 8. That 8 it goes with 4 and goes with -1. So the way I'm going to answer this is I'm going to say that it does not represent a function since there is one number in the input, which is a. So again, make sure you have the right one here. A is always the input, where there are multiple mappings in the output. So let me restate that as you see this. So it's not a function because there's a number in the input, that number being 8, that has multiple map mappings in the output because 8 goes with 4 and it also goes with -1. So that's what you're looking for in delta math when you're answering those questions. One last thing to talk about when it comes to functions, if it is visual, we can tell if it's a function by doing something called the vertical line test. So your vertical line test, I don't know if I can get rid of that. There we go. A vertical line test means that if you draw a vertical lines run up and down, and it passes through more than one spot on a graph, then it is not a function. We often call this the VLT, the vertical line test, and we talk about if it passes or fails the VLT. So if you look at this first picture here, this is a function. So you're looking at the blue curve here, and I'm just drawing a little red vertical line showing that no matter where I draw that line, I can draw a whole bunch of them, I am always going to touch that graph once and only once. That is an example of a function because it passes the VLT. If you have a spot in the graph or multiple spots in the graph where when you draw a vertical line, it touches the graph more than once, twice, 3 times, 4 times, it is not a function. So again, what we're looking at here, here's a vertical line that I drew, and it actually touches this function multiple times. So we would say that it is not a function. We would say that it fails the vertical line test. So some examples, if you think of like a circle, and I ask, well, is a circle a function? A circle is not a function because I can draw a vertical line and touch that circle twice. If you think about a parabola, trying to think of some of the shapes that you guys have used a lot, a parabola is a function because anywhere I draw a vertical line, it would only touch it once. If you look at something that kind of looks like a parabola turned on its side, it's not technically a parabola, but that's what people think of it as. This one is not a function because if I draw a vertical line, it touches it twice. So in delta math, let me go back and show you this. So in delta math, you're going to be asked to look at graphs and determine if there's a function. And the best thing to do is to take your finger, your pencil, and kind of hold it up to the screen and say, okay, if I draw a vertical line everywhere, will it only touch it once? And if it does, then you say it's a function. This one is. If, let me see if I can find one that's not. Perfect. We have this kind of square, it looks like. If I would draw a vertical line really anywhere in that square, it would touch it twice. So this one is not a function. So that's the basics of the beginning of the chapter that I want to make sure you're comfortable with.